Hello and welcome to Dr. T's Math. In this video we're going to review some exponents and log rules. Now let's say we have something like 10 squared. If we wanted to expand that, that's 10 times 10. And then 10 cubed is likewise just 10 three times, 10 times 10 times 10, and so on. 10 to the fourth is 4 tens, 10 times 10 times 10 times 10. And the same goes for any number, any integer, any number. Or x to the fifth is x times x times x times x times x. And if we wanted to multiply those, then we're going to add the exponents. So like 10 squared times 10 cubed is 10 to the fifth. And we can verify that by looking at these two together. There are 5 tens. And here there are 5 tens. Sorry, there are 4 tens. 4 tens there. And then if we had 10 to the fifth, then it'd be 10 5 times, 10 times 10 times 10 times 10 times 10. And what does that mean? Well, if we had 10 to the first power, well, that's just 10, and you can see that there's 1 0 after the 1. How about 10 to the second power? Well, that's 100. We know that, and there are 1 2 zeros after the 1, just like the exponent 2. 10 cubed is 100 times 10, or 1,000. You can see there are 1, 2, 3 zeros, and so we're seeing a pattern here, like 10 to the fourth is 10,000. There are 1, 2, 3, 4 zeros after the 1. And that follows, we can go over to the calculator and say 10. Now if we go a second log, it's going to have automatically 10 to the some power. 10 to the fifth, let's say, is 100,000 there. You can see there are 5 zeros. And at some point, it's going to start giving us an E, 10 to the sixth, 1 million, 1 with 6 zeros, 10 to the seventh, 10 million. Now let's do like 10 to the 20th. Oh, it gives us 20 zeros. That's interesting. How about 10? We can do it two different ways. We can type in 10 and then put the little caret underneath the clear. And how about let's do 10 to the 50th. That's not going to give us 10 to the 50th. It's not going to likely. It did. It showed 50 zeros. Well, on your handheld, it's not going to do that because there's just not enough space on the screen. It's going to show you something like 10E50, right? And that E is underneath the comma. E means exponential form, and so that's basically scientific notation. Scientific notation is when we have, now generally speaking, it is a number, decimal, and then there could be any number of places after the decimal, but it's going to be one place before the decimal, and it's going to be times 10 to the some power. So for example, 3.0 times 10 to the third power is just 3,000. 3,000, 1, 2, 3. And we can see if we had 3.0, we move that decimal place 1, 2, 3 to the right, put the zeros in front of the decimal, and then there we got it. The other way around, we could have, for example, 1.5 times 10 to the negative 3. And we're just going to move the decimal the other way. Oops, 1.5. And we're going to move that 1, 2, 3 places over here, put zeros, and we got 0.0015, go back to the calculator. Let's do 1.5 second comma, oops, 1.5 second comma, negative 3. And right there it is, 0.0015, or 3 divided by 2,000. Well, this leads into logs. Now remember, a log function is an inverse function. Inverse meaning, well, we know that 10 cubed is equal to 1,000, but say that we got the 10 and we got the 1,000, and we don't know the 3. That's unknown. And of course, it's fairly simple if it's just 10 and 1,000. We know, oh, we can figure that out fairly easily, especially with base 10 stuff. We can just divide this number by that number and divide it again and again and get 3 there. But with other numbers, it's not so simple. So if we just have log, then that base is 10. And generally speaking, we're going to have log A, B equals C, where A to the c equals b. It's kind of backwards. You can see that this is the exponent, this is the base, and that's the outcome there. And back on the calculator, you can see log there is above ln, below x squared. Now let's just do log, I had it backwards just a moment ago. Log 1000 equals 3. Log 1000 equals 3. Let's go back here. And we're just going to do log 1000 for simplicity's sake, and that, and we're going to get 3. And we could do that with any number. Log, let's try log 10, that's going to be 1. Any number raised to the first power is itself. How about if we did log 1? Well, it's going to be 0 because any number raised to the 0 power is 1. And again, that's right, it's no coincidence that the 10 to the power is right there beneath log. We do second. Log 0, well, that equals 1, so you can see these two functions, log 1 and 10 to the 0, are definitely related. Now let's go a little bit further and look at natural log. Well, if you've got log base a of b equals c, and generally speaking that's going to be a base 10, and then we don't even say that. So again, log of 1000 is equal to 3 because 10 to the third, what that means is 10 cubed is equal to 1000. There's this other thing called natural log. The natural log is just a fancy way of saying log base e. And e is roughly 2.72. Go back to the calculator, and we're just going to say second ln e to the first. It's like 2.718. This is just a special number that shows up in the real world very often. Mathematics is discovered. It's discovered through empirical methods. It's not really invented. Some of the notation is like language, and people decided to write things a certain way in order to standardize so that ideas can be communicated, but the actual topics and the concepts are discovered and not invented per se. And so this number 2.718, 2.72 is just a ratio that's found in the real world quite often, especially with regard to exponential growth and decay. And so what we got here is log base e. And a moment ago, you said log base e of like 2.718. Well, this is also e. E to the first is equal to e, just like x to the first is equal to x. So any number log 1 is equal to log base x of 1 is equal to x. Oops, sorry. Log base 1. Log base x of x is equal to 1. If we have a 1 there, then that's going to be equal to 0, which is part of our log rules. And so let's have a quick look back at the calculator and confirm that ln of e to the first, well, that's going to be equal to 1. Why is that? Because what we're actually saying then is log base e, this is ln, also known as ln, so ln e to the first is equal to 1 is what we found out. Log base e of e, well, that's equal to 1, right? Because e to the first power is equal to 1. So this is an inverse function. E to the first power, is equal to e. And so that's what we have here. We have e raised to the first power, and then that gives us e there. Or ln is actually log base e. And so e raised to the first power is e. Well, let's try something like ln of 1. That gives us 0. And let's just for confirmation's sake, go back to math, and then we're going to do log base, and we got log base e, and we'll have to put the first there. Log base e of 1 also gives us 0 because ln natural log is actually log base e. And what that means is log base e of 1 equals 0 because e raised to this is equal to that. Any number to the 0 power is equal to 1, and so that's how we get ln 1 is equal to 0. Now anytime you have something with like e to the 2x, and you want to do something, this is equal to something else, I don't know, 5x plus 3, and you're confused, well, oh, what do I do with this? How do I deal with this e here? Well, that's how we get taking natural log of both sides. Ln e to the 2x is just going to be equal to 2x, because these two cancel out, because log base e of e to the anything is just going to be equal to that anything, 2x, because that's the definition of a log. E to the 2x is equal to e to the 2x. And so that's how we get those patterns and those rules. Not just invented, not just like some artistic statement or something like that, but very much a matter of a discovery in mathematics. So you got e squared there, and so let's just confirm one more here since we got the calculator out. Ln base e squared is equal to 2, and that confirms what we had just a moment ago. So ln, in this case, x would equal 1, and so ln is going to be the same as log, go to math, and down to c, log base, we're going to get e to the first power, and then we're just going to put in e squared like we had there with ln, and it's going to turn out 2 for us. And so that's the definition of a log. It's an inverse function of an exponential exponent, and you can see how the progression works here. We just start out with basic exponent rules, and then a little bit of scientific notation, very similar and related, that we're just moving decimals one place or another. When we move away from the base 10, then we have that part in the log, which can turn into this e. E is just a natural number. It's a transcendental number like pi. And we can move back and forth between the exponent form and the logarithmic form. And when dealing with e as a base, we're just using ln. This has been Dr. D's Math. Thanks for watching.